Section 10-7, Volume of Pyramids and Cones. The objective of this lesson will be to learn and apply the formula for the volume of pyramids and cones. Okay, let's go ahead and first start with the equation for the volume of a pyramid, which is 1/3 times the area of the base times the height. Okay, so now this time we're using this height right here, which is perpendicular. When you are finding the surface area of a pyramid, you are using the slant height. So be careful as to which height you're looking for. In this equation, they want the height, and your height is always perpendicular to the base. So this would be your height. Example 1, find the volume of the square pyramid with base edge length 9 centimeters and a height of 14 centimeters. Okay, so even though it's not drawn in here, we know that the height, which is always perpendicular, right here, this is 14. Now the equation for the volume of a pyramid is 1/3 times the area of the base times the height. Now here our base is a square. We know how to find the area of the square. We just do the side squared. So 9 times 9 for the area of the base. And then we multiply that times the height of our pyramid, which is 14. Now that we have everything, we're going to go ahead and plug this in. And we get 378 centimeters cubed for our volume. So very basic, very similar to what you were doing yesterday for the volume of prisms and cylinders. We're just multiplying by 1/3 for our pyramids. Okay, example 2. Find the volume of the regular hexagonal pyramid with height equal to the apothem of the base. Now remember, here we have a regular polygon, and the apothem is always from the center down perpendicular to a side. Any of the sides is okay. So this apothem is the same length as the height, and your height would be right here, which would be perpendicular. Now right now we don't know the apothem, but we can figure that out. Okay, so here we have our hexagon. We know that this side is 12, but whenever we draw this triangle, our right triangle in here, we know that this is 6 for the base of this triangle. Now remember, to find this angle, you first need to find the central angle. We have 6 sides, so we're going to do 360 divided by 6, which gives me 60 degrees. Now that's my central angle. And since we know the apothem cuts that angle in half, we know that this angle here is 30 degrees. I need to solve for the apothem, this side right here. So we're going to use our trig. This is the opposite side. This is the adjacent side. So I'm going to be using tangent. So the tangent of 30 degrees is equal to the opposite over the adjacent side. And to solve for A, that comes out to be 6 divided by the tangent of 30. Now don't forget to be in degree mode whenever you plug this into your calculator. When you plug this in, we get 10.392. Okay, so that's the apothem, and that's also the height. So let's go ahead and plug in what we have now for the volume, which is 1/3 the area of the base times the height. Okay, so 1/3 the area of the base. If you've forgotten the area for the for a regular polygon, it's 1/2 times the apothem times the perimeter. So I'm going to go ahead and plug that in here. 1/2 times my apothem is 10.392 times the perimeter. Now this side right here measures 12, and then we have 6 sides, so it's going to be 12 times 6, which is 72. Okay, this whole piece right here, this is capital B, area of the base, and then we're going to multiply that by the height. Now the height is the same as the apothem, which is 10.392. Okay, now that we have everything, we're going to go ahead and plug that in and find our volume. Okay, and this comes out to 1295.92 feet cubed. Okay, so the hardest part of this was just finding the area of our polygon, because it's a regular polygon. We had to do some trig. The same concept, we're still doing area of the base times the height, but we're just multiplying by 1/3. Okay, now we're going to look for the volume of the cones. The equation here is also 1/3 times the area of the base times the height. Now for a cone, we know that we have a circle for the base, so they rewrote it here as 1/3 times pi r squared times the height. Okay, but it's still the same equation that we're using for the area of a pyramid, or sorry, for the volume of a pyramid. All right, so let's go ahead and try an example using the equation for the volume of a cone. It says find the volume of a cone with base circumference of 25 pi and a height of 2 inches more than twice the radius. All right, so we have some work here to do. Let's go ahead and first start drawing what we have. It's always nice to see what we have to work with. We know that the circumference, so all the way around the cone, the base of the cone, this is 25 pi. And the height, so remember our height is going to be perpendicular. This height right here is 2 inches more than, so more than means plus, more than twice the radius. Twice means 2 times. All right, so first I'm going to go ahead and start off with the circumference right here. We know that the equation for the circumference is 2 times pi times the radius. I know what the circumference is, so I'm going to go ahead and plug that in. So that's 25 pi. And the only variable I have here is r, which is my radius. So I want to go ahead and isolate the radius. And to do that, I need to divide by 2 pi. And what I do to one side, I must do to the other side. So 2 divided by 2 is 1. Pi divided by pi is 1. So those are gone. We have the radius. Over here, the pi's will also divide out to be 1. And I have 25 divided by 2, which is 12.5. So now I have my radius. So from here to there is 12.5. And I also know what the height is now. I know that the radius is 12.5. So I'm going to go ahead and erase that and put here 12.5. And when we plug that in, this right here is 25 plus 2 is 27. So let's go ahead and rewrite 27 here for the height. Okay, so let's go ahead and write the equation here for the volume of my cone, which is 1/3 times the area of the base times the height. The area of the base, which is a circle, is pi r squared. We know the radius. The radius is 12.5. And we're going to square that. So this is the area of the base. And then last, we have to multiply it by the height, which is 27. Okay, so now we have everything. Let's go ahead and plug that in. And I'm going to go ahead and leave this in terms of pi. It's not specific in the instructions, but it's just going to be nicer. So here we now have 1406.25 pi inches cubed. Alright, so we're still doing the same thing. This problem required a little extra work since it didn't exactly tell us the radius or the height. Okay, example 4. Find the volume of the cone. And so here we have the cone with a radius of 16 and a height of 34. So the equation for the volume of the cone is 1/3 times the area of the base times the height. The area of the base is pi r squared. We know the radius is 16. So we're just going to put that in here. And the height is 34. So this problem is pretty simple. They've given us all the information. Let's go ahead and plug that in. And I'm going to go ahead and leave this in terms of pi. So when I plug everything in, I get 2901.3 pi centimeters cubed. Example 5. Find the volume of the composite figure, round to the nearest tenth. So here we have 3 figures. We have 2 cones and a cylinder. I'm going to go ahead and work from the bottom up. I see this cone right here has a height of 40 and a radius of 21. So here I'm just going to label cone bottom, just so I can keep track of which one's which. So the equation for that is 1/3 times the area of the base times the height. The area of the base is pi r squared. We know that the radius of this bottom cone is 21, so 21 squared. And the height of that cone is 40, so from here to here. Okay, so let's go ahead and find that volume. And for this problem, we cannot leave it in terms of pi. We're just going to put it all together because they want us to round to the nearest tenth. So for this guy, I get 18,472.6. Okay, and now I'm going to find the volume of the cylinder. And if you remember this from yesterday's lesson, the volume of the cylinder is the area of the base times the height. Area of the base is pi r squared because we have a circle, so pi times the radius squared times the height of my cylinder, which is 35. Okay, so let's plug this in, and for this I get 48,490.5. Alright, one more shape. We have our last cone up here. This is the top cone. And the volume for that is 1/3 times the area of the base times the height. It has the same area of the base as this one does, which is still pi r squared. Radius is still 21. And now the height doesn't tell us specifically, but we do know that the height of the cylinder is 35. So from here to here, this should be 35. So now we just have to find what's left from here, because we know this cone and the cylinder is 70. So we're going to do 70 minus 35, which gives us 35. So I also know that this top portion is 35, which is the height. Okay, so let's go ahead and plug that in. And for that, I get 16,163.5. Okay, so now we're going to go ahead and find the total volume by adding all three of my polyhedrons, the two cones and the cylinder. So we have the bottom cone plus the cylinder plus the top cone. When we add all those up, we get a total volume of 83,126.6 centimeters cubed. So just break up your composite figure into shapes that you know and find the individual volumes and then just add all those up. Okay, so here's our assignment for this lesson. Once again, for Miss Allred's class, this is required. And for Miss Schrader, I'm going to go ahead and let her decide what she wants to do with the assignment. It says here, calculate the volume of the regular square pyramid. Okay, so make sure you use the equation, the appropriate one that you need, and find what you need, and bring your answer tomorrow to class.